Okay, so the next one is the inversion of a matrix. So inversion of a matrix. So suppose if I have a matrix A, so if I take the inverse of this matrix, it will produce the inverse of the matrix. So it is denoted as A minus 1. So that is the idea about inversion. So if I take AB equals to BA, and if it produces the identity matrix, so such a B will be inversion of that specific matrix. So this is the theorem. AB equals BA equals IN, then B will be A inverse. Okay, so that is the basic idea about matrix inversion. So let's grab some example. So let's say I have this matrix, and if I wanted to find the A inverse, all I have to do is following this rule: AB, BA, IN. Okay, so suppose I using these two methods. AB equals to IA, so AB equals to IN. So A will be 2, 5, 1, 3, and B I don't know, so I will put as A, B, C, D, and IN I know, which means 1, 1 and 0, 0. So now let's product this matrix. So it will produce 2A plus 5C, then A plus 3C, then 2B plus 5D, then B plus 3D. So now I have 4 equations. So I have to solve this. 2A plus 4C equals 1, A plus 3C equals 0, then 2B plus 5D equals 0, then B plus 3D equals 1. So A will be equals to minus 3C. If I feed this to this, then 2 minus 3C, 5C will be 1. So minus C will be there. So the C will be 1. So if C is 1, then A is minus 3. Likewise, B will be 1 minus 3D. So if I feed to this, minus 3D plus 5D will be 0. 2 minus 6D, and 5D will produce minus D. So D will be 2. So since I have in D, the B will be 1 minus 6, which is minus 5. So now we know ABCD, which means B is minus 3, minus 5, 1 and 2. So the rule is, if I write a matrix like this, then B will be the inversion of the corresponding matrix. So this is the inversion of it, and that is the way to find the inversion. And again, this is not the efficient way to find the inversion of a matrix. This is not the efficient. This is not the efficient way. So in later we discuss some other new topics as well. So it will be easier to find this inversion. But this is the general case, and that is how we find the inversion of a given matrix. And there are some specific theorems as well, or specific rules that are associated with this inversions. So I'm not going to prove those, I just stating. So I just state the theorems or the rules. The first rule is, if you take the inversion of an inverted matrix, it will produce the relevant matrix. And if you take the inversion of a scalar multiplied matrix, so the scalar will be inverted like this, and this will be inverse. The third theorem will be, if you take the inversion of a product, then the values will be swapped like this way. And the fourth and the last one will be, if you take the inversion of a transpose matrix, you can write it either like this. You can take the transpose of the inverted matrix. Right? So those are the 4 rules that are associated with matrix inversion.